Hello everyone, I am Ashwin Akash from AIS department 3rd year. Today we are going to see about MLP implementation for nonlinear data. Introduction to multilayer perceptron. Basic structure. A multilayer perceptron consists of an input layer, one or more hidden layer and output layer that are interconnected through adjustable weights. Then activation function. Nonlinear activation functions such as ReLU or sigmoid allows MLP to model complex relationships essential for nonlinear data, where the ReLU is called as rectified linear unit. Then learning process. MLPs are trained using backpropagation, which iteratively adjust weights to minimize the loss function through optimization techniques. Next, handling nonlinear data. Challenge of nonlinearity. Traditional linear classifier fail with nonlinearly separable data, necessitating complex models to capture intricate patterns in the data. Next, hidden layer role. Addition hidden layers is in an MLP enable the network to learn hierarchical feature representation effectively, transforming input data into a more separable space. Next, use of regularization. Technique like dropout and L2 regularization helps prevent overfitting, ensuring that the model generalizes built to unseen data while still capturing non-linear relationship. Next, implement and step of model training. Data preparation. Pre-process the data set for better performance. Then define layers and nodes. Experimentation may be necessary. Training the model. Use optimizer and monitor loss and accuracy during training. Next, performance evaluation. Metrics for assessment. Employ metrics like accuracy, precision, recall, and F1 score to evaluate model. Next, cross-validation techniques. Apply k-fold cross-validation helps in assessing the model's robustness and ensure that the performance across subsets of the data. Next, visualization tools. Utilize confusion matrix and receive operation characteristics curves to visually interpret model performance and make informed change in necessary. Challenges and solution in model training. Overfitting. Mitigate through regularization, dropout techniques, and acquiring more training data. Class imbalance. Strategies like resampling, adjustment class weights, or cost-sensitive learning can enhance model effectiveness. Hyperparameter tuning, grid search, random search, and automated machine learning framework facilitates this process. Next, case study and result. Example dataset. Description of dataset like the Excel problem to illustrate MLP effectiveness. Graphical representation. Plot comparing decision boundaries of MLP and linear classifier. Comparative analysis. Result shows casing MLP performance versus other classifier on nonlinear separability. Conclusion of MLP. Effectiveness of MLP. MLP has proven to be a powerful tool for classifying non-linearly separable data. Future direction. Exploring advanced architecture like CNN and RNN may provide more significant gains. Ongoing research. Research in interoperability, efficiency, and architecture optimization will improve the MLP application. Now we are going to the coding part. Initially, get the NumPy and Pandas and input OS. Next, get the matplotlib for visualization. Now get the two matrix of arrays, then mean, then get the values of that sample values, then get the M array as shape of 1. The learning rate should be 0.1. Random seed. We use random seed to get the random values. Let's get W1, W2 as the random values. Now apply the sigmoid function, which is called as an activation function. Then forward propagate the values. Get the dot value and apply the sigmoid function. Again get the second arrays and get again the sigmoid function. Then return. Then do again the back propagation to get the updated values. Then return those values and iterate up to 10,000 data sets, where the forward propagation will get W1, W2, X, where the data set, and find the losses, where we use the sigmoid function of the losses. Then append those in losses list, then get the back propagation and find the values for those. Then plot the losses and showcase it in the x-axis and y-axis approach and loss value. Now predict those using forward propagation. Now get the values of W2 and W1. Then if A2 is 0.5, then print it on the first value. If else, print it at the zeroth value, zeroth axis. Now input and output. Now we can use to predict this in using the values, where we can get 1 0 means 1, 1 1 means 0, 0 1 means 1, 0 0 means, which is showcased as an XOR table. Then where the loss function will be at 0.8 to 0.7, then it will come lower to lower, which will function the loss values in decremental order. This is the program of given MLP implementation. Thank you.